Hello everyone. In this video we'll continue our investigation of the connections between the word, table, graph, and equation representations for linear relations. We'll also discuss direct variation and partial variation and talk about how the type of variation plays a role in each of the four representations. So let's get moving. In this example we have a word description which says that Amal starts with $400 in her savings account and deposits $50 every week. So every week she's putting another $50 into the account. Now, as is the case with all linear relations, there are two important values we need to consider, and those are the start value and the rate. And we're given both of those here in our word description. So let's write those down. We have our start value, which is the amount that she started with in the account, and we're told that that's $400. And we have our rate, and that would be the amount that she's depositing each week, and we're told in the word description that that's $50. So we can write $50 per week. Now let's quickly take a look at how these two important values appear in each of the four representations, beginning with the start value. In our word description, we've already seen that the $400 start value appears right here. It's explicitly stated that that's how much she starts with in the account. Looking at the table of values, we see our start value of $400 right here. And notice that that corresponds to a time of 0 weeks, which is what makes it the start value. Looking at our graph, we see our start value of $400 right here on the vertical axis, again corresponding to a time of 0 weeks. And finally, in our equations, the $400 start value appears as the number that does not have a variable with it. That is, it is the constant in our equation. And we have two different forms of the equation here. One has the start value written first, the other one has the rate written first on the right side, but they both represent the exact same relationship. Now let's check out how our rate of $50 per week appears in each of these representations. In the word description, we're told that Amal deposits $50 every week, which makes the rate $50 per week. To find the rate of $50 per week in the table of values, we have to do a little bit of work. Notice that from the first row to the second row of the table, the amount has increased by $100. That is, from $400 to $500. But looking at the left side of the table, we see that that increase occurred over a time period of 2 weeks. That is, from the 0 week point to the 2 week point. So to find the rate, we just need to take the increase in the amount, which is $100, and divide it by the 2 weeks that have passed. This will tell us how much the amount has increased per week. And when we do that, we get 100 divided by 2, which is $50 per week. Notice that you can do this calculation with any two rows in the table. For example, if I chose the next two rows, again, we have an increase of $100 over a time period of 2 weeks. So our rate could be found by doing 100 divided by 2 again. Now there's no rule that says you have to use consecutive rows of the table. For example, you could choose to go from this row to this row, in which case the amount has increased from $700 to $1,000, which is an increase of $300. And that increase occurred over a time period of 6 weeks. That is, from the 6 week point to the 12 week point. So if we do 300 divided by 6, we'll get our rate of $50 per week. So you can see how our rate appears in the table after we do a little bit of calculation. Looking at our graph, we can see our rate of $50 per week as the amount by which the graph increases over a 1 week time period. So for example, if we took our initial value of 400, moved over 1 week, which on this graph corresponds to 1 space or 1 square, and then moved up to the point on the line, we'll see that we've increased or gone up by $50. Notice that on this graph, 1 square or 1 space on the vertical axis represents $50 because 2 squares or 2 spaces represents $100. And you could do this for any pair of points. So for example, if we chose this point here, move over 1 week and move up to the line, we'll see again that we've increased by $50. And you don't have to use adjacent points. For example, if we chose this point right here and this point right here, we simply need to look at how much we've moved over, which is the amount of time, and how much we've moved up to get to that next point, which is the increase in the amount. And looking at the axes, we see that we've moved from 8 weeks to 11 weeks, which is an increase of 3, and we've moved from $800 to $950, which is an increase of $150. Now if we take that $150 and divide it up by those 3 weeks, we'll see we've increased by $50 per week. And that's how the rate shows up in our graph. And finally, looking at our equation, we see that our rate of $50 per week shows up as the number in front of the variable representing the number of weeks. To determine if a relationship is an example of direct variation or partial variation, you may have heard of a little shortcut that states if the start value is 0, you have direct variation, and if the start value is not 0, you have partial variation. This is actually true, and we'll look at it in a little more detail later in the video. But for now, realizing that our start value is 400, which is not 0, we can say that we have partial variation. Now let's take a look at a slightly different relationship. Here we have Nathan, who starts with nothing in his savings account, and like Amal, he's depositing $50 every week. So we still do have our start value and our rate. In this case, our start value is actually $0 because he's starting with nothing in his account. And the rate, as it was in the previous example, is $50 per week. Once again, let's quickly look at how these two important values appear in each of our representations, beginning with our start value. Our start value of $0 appears in the word description when we're told that Nathan starts with nothing in his account. In our table of values, we can see our start value of $0 right here, which again corresponds to a time of 0 weeks. Looking at our graph, we can see our start value of $0 right here. It's the point on the vertical axis corresponding to a time of 0 weeks. Notice in this case, that point is right on the graph's origin. And finally, looking at our equation, we see our start value of $0 as the constant in the equation. Notice that since we're just adding to 0, it's not necessary to write the 0. We could just write A equals 50 times the number of weeks, or A equals 50n. The rate of $50 per week appears here in the same ways that it did in the previous example. In the word description, we're told that the $50 deposits are made every week, giving us a rate of $50 per week. In the table of values, we can find the rate by taking any two rows and finding the change in the amount, which here would be an increase of $100, and dividing it by the change in time, which here would be 2 weeks. So if we do 100 divided by 2, we get our rate of $50 per week. Again, we can use non-consecutive rows of the table. For example, if we go from here to here, we've increased from $400 to $600, so that's a change of $200 over a time period of 4 weeks, from the 8-week point to the 12-week point. So if we do 200 divided by 4, we once again get our rate of $50 per week. Looking at our graph, we see the rate of $50 per week as the amount by which the graph increases over the period of 1 week. And once again, we can make this calculation using points that are more spread out on the graph. If you choose this method, don't forget to check the scales on your axes. And last but not least, looking at our equations, we see our rate of $50 per week again show up as the number in front of our variable representing the number of weeks. And finally, we see that here we have an example of direct variation since our start value is 0. We've already talked about how having a start value of 0 implies that we have direct variation, and a start value that's not 0 implies partial variation. But why does that matter? Is there anything more to it? Well, it turns out that there is. In fact, if we have direct variation, something really nice happens. To see, let's start by taking a look at our table of values. Remember that we found our rate by taking the change in the amount and dividing it by the change in the number of weeks. This approach will always work for finding the rate in a linear relation. But it turns out if we have a direct variation, we can get this result a little more quickly. Specifically, if you have direct variation, as we do here, you can just use a single row from this table to find the rate. For example, if we choose this row here, we can simply take our amount of $100, divide it by the number of weeks, and get our rate of $50 per week. This will work for any row in the table. For example, if we chose this last row, we could take our amount of $600, divide it by our number of weeks, which is 12, and again we'll arrive at $50 per week. Please note that this approach only works if you have direct variation. As we'll see momentarily, if we have partial variation, we cannot do this. We can do the same sort of calculation using our graph. For example, we can take any single point, perhaps this one right here, which corresponds to an amount of $150 and a time of 3 weeks. Calculating 150 divided by 3 gives us our rate of $50 per week. No matter which point we choose on this line, we'll arrive at the same result, but again, this only works when we have a direct variation. So why does this happen? Well, it turns out that if our start value is 0, that is, if we have direct variation, we have a proportional relationship. And what that means is one variable is always the same multiple of the other variable. So in this case, we can see that our amount is always the same multiple of the number of weeks. This is really easy to see if you look at the equation in this form. Notice that our amount is always 50 times the number of weeks. Looking back at the partial variation example with a mall, we do not have the case where the amount is simply a multiple of the number of weeks. We can see that in the equation by noticing the addition of 400. Therefore, looking at the table of values in the graph, we cannot find the rate by simply dividing the amount by the number of weeks. For example, if we did 600 divided by 4, we would get 150. But if we do 900 divided by 10, we get 90. These values are different, and therefore we do not have a proportional relationship, which means we do not have direct variation. Instead, we have partial variation. Similarly, with the graph in this relationship, we cannot find the rate by taking a single point and dividing the amount by the number of weeks. Instead, if we want to find the rate, we must compare the change in the amount to the change in the number of weeks.